My name is Chris Ng, and I'm from Veracode. I'm here to talk to you today about security scoreboard in the sky, which I'll explain. This is not about the security of cloud-based applications, which actually was a misconception that I can see why some people made. But in the sky actually refers to the method by which we collected the data. So this presentation is about some observations we made based on a large data set of application flaws that we've collected over a period of time. So just quickly, if you saw my yesterday talk, sorry you've already heard this, but basically I work for Veracode. I'm the Senior Director of Research at Veracode. And my job is mainly to run the security research team, which our main responsibility is to write specifications and test cases for our engineers, so they know which types of security flaws are important and how to detect them. We research new languages and platforms. We speak at security conferences. We work with customers to discuss findings, get their feedback, and so on. My previous experience has mostly been in consulting, with a lot of penetration testing background and offensive security research. And those are some projects I've been involved with on the security community. The most recent one has been working with MITRE to help develop the CWE SAM's top 25 most dangerous programming errors. So normally I wouldn't talk too much about the company, but in this case, it's actually important that you understand kind of how our service works and how we collect the data, because that affects the rest of the information in the report. You need to understand where the data is coming from in order to understand any biases or any understand how we're viewing it through the lens of our service. So our company was founded about 4 years ago, 2006. And what we do is we provide software security analysis as a cloud-based service. Our core technology, the one that we hold a patent on, is static binary analysis, which models the behavior of a program without actually running it, which is in contrast to a dynamic analysis or a pen test where you're actually testing against a live running system. So in static analysis, we're detecting flaws by building a model of a program and then searching that model for patterns that are indicative of security vulnerabilities. So we know, for example, what cross-site scripting looks like in our code model, but we don't actually run the program and try and figure out which specific attack vector may cause an exploit to happen. We're looking for patterns. So our customers upload their compiled applications through our website. We scan it on the back end, and then we report results to them through the website. Now, while our core service is static, we also do dynamic analysis using an OEM of a third-party web scanner. We also do manual penetration testing, and that's all also controlled and managed through our web-based platform. So one of the residual effects of our cloud delivery model is that over the years we've amassed quite a bit of vulnerability data. And the results of every analysis we do feed back into that platform. So every time we do another analysis, our data set grows. So then what we can do is we can anonymize the data and generate security metrics that give us insight on the current state of software security. And that's a capability that's unique to a cloud-based or a SaaS-based offering, similar to the talk that you may have just seen that Tom Brennan just did. Only these SaaS-based companies have this information. Anybody who writes an on-premise tool for analyzing software never gets those results back, and so they can't anonymize them. They can't look at trends over the industry like a cloud-based provider can. So this is an example of some of the data that we have as a result of the analyses that we do. So for every application in the green in the upper left, we ask the customer for some information about the application that we're scanning. What vertical is their company in? What type of application is it? Where did it come from? Did they build it themselves? Did they purchase it? Is it partly open source? How critical is the application? That's what assurance level means, and we'll talk about that in a couple slides. what language is it written in, what platform is it intended to be deployed on. And then when we actually do the scan itself, we generate a bunch of other metrics. So how often has it been scanned? When was it scanned? How big is the application in terms of lines of code or size on disk or whatever metric you may want to use? What are the flaw counts? How severe were those flaws? What was the rating? How many applications passed on their first scan? How long did it take them to get to a point where they did pass? And we'll also talk about what pass-fail means in the context of our service. We can look at different slices of flaws that we detect. So which one of those fall into the CWE SANS Top 25 taxonomy? Which ones fall into the OWASP Top 10? And we can basically ask any questions that we want of this data set. So a few months ago, in March, we published a report, which is our first version, our first release of the State of Software Security report. And this included data from over 1,500 applications and several billion lines of code over a period of about 18 months. And this is a free report. It's available on our website, and it's something that we're going to release or we're going to update every 6 months. So the next one is going to be due out in around the July or August timeframe. So the rest of this talk is discussing the conclusions that we made based on the data in this report. So quickly, how this is the kind of distribution of the applications that were in the data set. There are a few things that I want to point out. Number one, if you look at the supplier graph in the upper left, 60% of the applications were internally developed, 30% were commercial, and in this case, commercial generally means ISVs. By industry, financial and software are the highest represented industries. There are about 15 or so different verticals represented in the data set, and most of those make up the other category, the 32% of other. So that's partly a reflection of our customer base, but also a reflection of who's producing the most software. And then by language, Java kind of beats out the rest of them. I think this is reasonable, again, a reflection of our customer base, but 47% of Java, a lot of enterprise development these days does take place in Java, so that's not an unreasonable number. .NET seems a little low intuitively, but it's not surprising to us that Java came out on top. I'm not a statistician, so I'm not going to go through each of these bullets, but the main thing to take away from this slide is that we had Betsy Nichols, who is a well-respected expert in the security metrics space, review our data set and the conclusions that we made, just to make sure that our sample size was large enough to be statistically significant, and the things that we were saying were things that should be said about the amount of data that we had. Betsy has a PhD in math, and she's one of the organizers of the what's it called? Security Metricon, and she's a contributor to the security metrics book that Andrew Jakewith wrote. It's just very, very well versed in the space. So these are our 7 observations that we made in the report, and we'll go through each of these in a little bit more detail, so I won't read them to you. They're here primarily for if you take the slides back and just want a quick reference. So each one of these we'll do a couple slides on. The first finding, and some of these you probably look at and say, well, that's pretty obvious. There is a lot of kind of conventional knowledge that we are trying to verify, I guess. So most of us are fairly familiar with the idea that most software actually is very insecure. Most of the time we say that, we're basing it on our own personal experiences rather than hard data that we can back it up with. So what we found was that 42% of all applications pass, or that 58% of applications fail to achieve an acceptable rating. And what I mean by acceptable rating here is that it's an acceptable rating according to Veracode's risk-adjusted score. And we'll talk about what the risk-adjusted score means. So 58% is pretty bad. If you spin it the other way around, you could say, well, 42% is pretty good. But on the other hand, these are self-selected applications. So these are companies that already have an interest in security. They are taking a proactive approach. These are the ones where they maybe the more critical applications in their inventories. So you could look at it and say that 42% may actually be a best case scenario. If you looked at all applications and the companies that aren't even thinking about security, the number's going to go way down. So that's a little discouraging. This is how the risk-adjusted rating system works. This is important to understand. When we do an analysis, we start with a score of 100 points. And for every, based on the number of flaws that we detect and the severity of those flaws, we deduct points from 100. And there are logarithmic elements to the formula so that if you have like 100 or 1,000 of the same type of flaw, they count progressively less against your score as you go on. So now you've got a number between 0 and 100 after we've deducted our points. Then to determine the rating based on that raw score, we use the assurance level or the criticality of the application. This is something that I alluded to before where a business needs to say, well, how critical is this application to my business? So that's on a 1 to 5 scale. We left 1 off because usually if something's that, very low criticality, you're probably not going to be assessing it for security anyway. But an example of an AL5 application is something that may be life or limb. It's like a dosing system or a flight control system or something like that. Or something that is just not life or limb, but so critical to the business that if it were breached, your company would go under or it would just be a major, major financial loss. An AL3 application, on the other hand, may be something that is internet connected, so it's publicly available on the internet, but doesn't process any really sensitive information. So companies will have rated their application before they did the analysis based on how critical it was. So now you have that 0 to 100 score. You take the row that corresponds to the assurance level that the application is at, map the number to a letter grade. And so when I say in the previous slide that 42% of applications passed, what I mean is that they received an A rating at the assurance level that they were defined at. Basically what this does is it lets you have a higher risk tolerance for the applications that are less critical, which makes sense, right? If you have something that, internal applications on the internet that publishes your cafeteria menu to your employees, you're probably willing to tolerate a lot more risk and a lot more vulnerabilities in that application than you are in your transactional consumer trading application. So it kind of makes sense to have a risk-adjusted metric for this sort of thing. So now we can break down the 42-58 split by looking at it by supplier. So internally developed apps here are slightly ahead, 49% passing, so that's above the average of 42. And this could be because enterprises are choosing to participate in the security process. They may be just more security conscious or more advanced than average. Commercial software, on the other hand, is faring the poorest at 29%. And again, we're mostly talking about ISVs. One of our common use cases is having an enterprise that uses a piece of third-party software, either incorporates it into something that they're writing, as, for example, a library, or they've just purchased a piece of software outright to use maybe to run one of their critical systems. You can think of something like PeopleSoft or Oracle or a piece of software that you just may purchase and introduce into your organization, which introduces some risk. So what happens a lot of times is that enterprises will ask us to have one of those third-party software vendors assessed for security. And so a lot of the commercial suppliers here fall into that kind of use case. So in those cases, maybe the ISVs are being pushed by the purchasing enterprises to do the security. Maybe they haven't done any security before. They're not as prepared to be assessed. And that could account for their pass rate being significantly lower than the average. A lot of the smaller software vendors that we assess, some of the mom and pop shops, 5, 6 developers, had never conducted any security testing before. We were the first